Alright, I have not made a video in quite a while. I've had this radio out in the barn, and I've just wanted to work on it forever now. And I finally have time to do it. So, today I'm going to show you the steps I go through when repairing an old radio. Now this is a Truetone model D1041 from around 1940, 1941. And it has 9 tubes, so it'll be plenty sensitive. I don't know how many bands it has. Probably, well, it's an AM radio, probably has short wave as well. This has 2 output tubes, so it'll have very good volume, plenty of power. Okay, first thing I do is I give it a visual inspection. Now we look and we make sure all the tubes are present and accounted for. And I've already looked on the schematic. They are all in the right places. Well, we got some dust, we got some rust on it. I do know the set kind of sort of works, but it's not safe to operate it as it is until we restore it. Change a couple key components that are failure prone and such. Now, I do know this can is a replacement, and I'll show you how I tell that when we flip it over. I think that's all up here. Okay, the set has 9 tubes. I did not count this I tube because it'll have no effect on the performance. But it has 10 tubes if you count this I tube up there. And this does have an audio input jack where you can plug in a television or phonograph, it says, and use this set's audio amp and speaker. Now it's very cool it has that, and it's like that from the factory, because we can actually plug our phone into this and play YouTube through it. And that's very cool. Now even if it didn't have that, we could still add one. It would be no big deal. Okay, let's flip it over. And there we go. I've already cut this big beast out of here. This was right over here. And here's one lead going to ground. And here's the other one. Now this is an electrolytic. And this was put in after the fact. This is a replacement. This is not factory. It's the wrong value anyway. Now, I'll zoom the camera in. And I'll show you how I tell that this can is a replacement. Okay, look at this solder job here. Look at how messy that is. That is not factory at all. So this can was replaced sometime in the past. Now it's a pretty old replacement, so it's hard telling when, but probably in the 50s or 60s. There's no date code on the can, so I can't tell. Alright, but the first thing we're going to do is change these electrolytic capacitors, because, like I said, this one was added in there. These are very failure prone, and when they go bad they can harm other components in here, and they cost like $0.25 a piece. So right here's one. I'm going to use these. I've got 3 of them here, and there's 3 separate ones inside this can. I've got them all right here. 15 microfarad at 450 volt. The ones in this can are all 10 microfarad at, I think, either 400 or 450 volt. And it's just so easy to replace them. Like I said, they cost $0.25 a piece, so why not? And when they go bad, they can burn out chokes and transformers. They could even catch on fire. So we're going to start with them. I'm just going to take these, I'm going to nip those wires off. There's one. cut this off here. Okay, here's one, and that is connected to the speaker jack. I'm just going to nip that off. Check our soldering iron here. It's been heating up. And it's cold out here, I'm shaking. I'm going to add some fresh solder to it. I'm going to connect one of these on there. Maybe, hold on. There we go. Wait for it to dry, cool down, I mean. I'm going to nip off the excess. Okay, and this other lead, this is the negative side. We're just going to connect it to this metal chassis because it's grounded. I'm going to solder it right where the can is soldered onto the chassis. I need to get that. Let me cut this thing off first. Okay, I'm going to try this. I don't know if I can. You need a really high-powered soldering iron to melt this stuff when you're soldering to the chassis. I think it went. Yes, sir, it sure did. Alright, so what I've done is I've removed one lead here. See, there's 3 different capacitors inside that can. They put them in the can like that to save room, because back in the day they had to be this big. I mean, now we've got little small ones like this, but back in the day they were huge, humongous ones. So I have disconnected the old one and put the new one right in its place. Now we're going to leave this can sitting there just for appearances. You won't even be able to tell that this radio has been worked on unless you flip it over and look at the bottom. Now I'm going to do these next couple. I'm not going to film it. So I will return the next part. Okay, I've just got done changing those other 2, and I'll zoom in and show you what I did here. Okay, that's the one I did before. Here's the other one. For this one, I nipped off that little stud that connected. Oh, my hand's in the way. It connected down here. I just chopped it off. Brought it up here, so it is now electrically disconnected from that old one. And this one is in its place. I've bent it so it's not going to touch anything else. And then the negative lead goes right to where the can was soldered. Okay. The other one is down here, around this tube pin. And the reason I did that was because there was a wire that came along here and connected to it. Just one wire. So I chopped it off right here, followed it over, and it connected right here. Now there's no reason to have it over here with the other 2, because I didn't have, well, I guess I've got plenty of room, but It's just so much easier to put it right here. And so there's the positive, and then I found a negative spot right here. These two pins of this tube are soldered to the chassis, you can see right there. So, yeah. And I've been saying positive and negative. See, these are electrolytic capacitors. There's only 3 of them in this set, and they are polarized, which means they have a positive and a negative. You cannot switch them up. If you put them in there backwards, they will blow up and scare the hell out of you. I can speak from experience on that one. I have double checked these are in here the right way. So now the next ones we're going to do, let me zoom that back out. I've got the camera a lot closer this time. I noticed the first time it was kind of far away. It's a lot better now. So now we're gonna change these. These are all these little waxy things. These are regular capacitors, and they're paper and foil and wax, and it's all wrapped up. Anyhow, they're bad. They're old and they're bad. They get leaky, electrically leaky. See, a capacitor blocks DC current but passes AC current. It just acts as a resistor to AC current. But these old ones are made out of paper, and you can tell in old books how that the old paper in books turns yellow and it turns acidic. Well, in these it does the same thing, but it turns conductive. So now these start to pass DC current, and that can burn out. It's hard on tubes, it stresses them, and like I said before, they can even heat up and they can blow up, or they can short, just completely short and really blow some stuff up in here. Some really expensive and hard to find parts, like this power transformer. That would be 30, maybe 50 bucks if you could even find one. Now why not just change this little capacitor right here that costs $0.25. Okay, and these are non-polarized. It doesn't matter which way you put them in there. It'll still work fine. Okay, we're going to do one over here. I'm going to zoom it in. That looks good. We're going to do this one right here. And if you can read, this says 0.05 microfarad at 400 volts DC. Now, I can get one. Let's see, 0.05. I've got one right here. Here's the modern replacement. And there's a size comparison. These old capacitors are a lot bigger because their technology wasn't as advanced back then, and they had to make them much, much bigger. But there's a size comparison. Okay, the easiest way to do this is just nip off both ends. And there we go, it's out. Let me get it in the camera here. Sprig. Okay, and our new one, we're just going to put it right in its place. We're going to take the old leads and we're going to bend them just like this. This is called J-hooking. And that makes it to where, hold on here, makes it to where we can just hook the new one right in here and solder it. So much easier. There's many methods of doing this. There's the pigtail method. There's J-hooking. Or you could, I could have just unsoldered the old capacitor right here and right here on this pin and hooked the new one straight to this point and this point. But J hooking is so much faster. Okay, we're going to cut off the excess. Let's see if I can get this. Okay, there it is. And we've got about 15 more to go. So we're going to go through this radio. I'm going to do it off film. And we're going to change every single one of these. And I'll be back before you know it. Okay, I've got the ones in this section changed. All these little red things are the replacement ones. And down here are the ones I've taken out. And I've got a couple more. And when I said in the last part I've got 15 more, well, that was kind of over exaggerated. I counted them and I only had about 10 more. But still, see, I've got these two, which I'm going to demonstrate how to change those now, because they've got this band around them and it's riveted. And these are actually big ones. These are, I believe, 0.25 microfarad, whereas all these over here were like 0.005 and 0.01. So they're pretty small. And then I've got 1, 2, these over here. Those will be a little bit harder because they're in tight spots, but they won't be too hard. Okay, something else I thought I had better talk about further was this electrolytic can. And hold on, I'll show you one. So here's one I just pulled out of the scrap pile, and this is the exact same. It had a 4, actually 2 4s, one at 300 volts and the other at 450 volts. And the red is the 4 at 450. Now on the bottom here there's the red. And this used to have a little tab on it you could solder onto, but it's broken off long ago. Anyhow, so there's one capacitor connects right here at the positive end, and the other one connects right here, the positive end. Now both of the negative ends of those capacitors are tied together and connected to the outside of this metal can. Now here's another one. This is an old style. This is a wet electrolytic. Had like jelly in it, but it's hollow now. And this only had one capacitor in it. But here was the positive end, and the negative end was connected to this metal can, and then just screwed into the chassis, and you can see where the wires were soldered onto it. Okay, now that that's over with, I'm going to show you how to change these. Now I'm going to nip off this end. Okay, and it goes straight to this terminal, so I'm just going to cut that lead right off there. Okay, and this is a 0.25 at 400 volts DC. I'm going to see what I've got over here. I've got quite a big selection. I'm going to, right over here. All these drawers are filled with different values of capacitor. And what I want a 0.25. I've got a 0.2 and I've got a 0.3. It's always better to go up, slightly up in value, than to go down. So I'm going to put a 0.3 in there. So I'm going to grab one, and this is at 630 volts. The one here is only rated for 400. It is always okay to go up in voltage, but never okay to go below. Whoops. I knocked my phone out. Let me get it back in here. Okay, now here's a size comparison again. And these other ones are quite small. This one's pretty big compared to these other ones. Quite small compared to this one. Okay, so I've already nipped one end off. So I'm going to solder one end of this to right here. I'm going to put some fresh solder on this joint right here. And I'm going to tin, what's called tin, one end of this capacitor. See, I applied solder to this one end. That's called tinning the lead. So I'm just going to solder it right on here. See, when you tin the leads, it makes it much easier to solder. Okay, there's that. So I'm going to solder the other end to right here. This is where the other end of this capacitor is soldered. It has this band around it and it's riveted, and you can see that the lead on top here just goes down and is soldered to this band. So I'm going to solder this cap to right here. I'm going to cut it to length. Slightly longer, I'm going to kind of wrap it around. Trying to get my hand in the way here too much. Okay, and again we're soldering to the chassis, so okay, that turned out nicely. That melted it pretty quick. Wait for it to cool. And there it is. This one is electrically disconnected, but I'm just going to leave it in here because it's riveted in there, and just be easier to leave it in there now. This one is the exact same way, and I believe it's the same value, 0.25. So we're going to do the same exact thing. Cut that. I'm going to move the camera a little bit. Okay. And we're going to cut this. And it was connected right to this point right here. We're going to get another 0.3. And we're going to solder it to that point right here. Whoop. You can't let it move before it's cooled, else you won't get a good connection. Okay, and again, the other side of this cap is just grounded. So we're going to find a spot on here that's grounded. Well, hold on, let me look. See, this other one has a point right there, but I don't have one right here. I'm not seeing one. Okay, right here there's one. We're going to have to bend this down. And I'm going to cut this. Bend it up. And, boy, this is awkward. Anyhow. Okay, and now we're going to solder it. It's always fun doing this in tight places because you got to be careful not to burn anything else. Okay, that took just nicely. So I'm gonna start doing these two over here, and then we'll be back for the next part. We're gonna have to check all these resistors in here. These right here are resistors. Now these are old style ones. They're called dog bone resistors. Here's another one. And here's another one. And I'll show you how to read those. There's color codes that corresponds to a number, and you have to decode it to figure out what numbers are on these and what value they are. And with them being this old, the value of them starts to drift, and if it drifts too far off, like say beyond 20%, we're just going to do 20%. If it's 20%, more than 20% above or below, we're going to change it. Okay, see you at the next part. Okay, now we're talking about resistors. So resistors have a color code to them. And here, I've drawn out, here's a dog bone resistor, which is what we're going to be dealing with in this set. Modern resistors are shaped a little differently. Okay, so we've got the different colors, and they correspond to a number. And I've got a chart drawn out right here with all the numbers. So a dog bone resistor looks like a dog bone. That's what this is right here. And it's got a colored dot. It's got the whole thing as one color, and then a different colored dot, and then one of the ends is a different color as well. And how you read them: bed, body, end, dot. So if we were going to read this, we would read body. What color is the body? It's yellow. So yellow is 4. Okay, the end is black. Black, we look up here, what's black? Oh, it's 0. So 0. Okay, the dot is orange, so it's a 3. But since that's the last number, we're not going to write a 3 here. The last number means how many zeros is behind this. So it would be 1, 2, 3 zeros. So that is the value of this resistor. 40,000, and resistors go in ohms, which looks like an upside down horseshoe. Capacitors go in microfarads and farads and nanofarads and picofarads, while resistors go in ohms. And coils are let's see, what is that? Oh, henries, millihenries, microhenries. That's inductance. Anyhow, we're dealing with ohms, which is this horseshoe thing. So 40,000 ohms. Let me get my camera situated again. Come on now. Okay, and it makes it a lot easier if you memorize what number, or I'm sorry, what color is what number. But in case you can't, which I can't, I haven't done this stuff in 6 months now, so I've forgotten them all. I've got this chart. You plug in the 3 colors, and you turn it, and like a red, you read down here, it's 2. And right here, white is 9, and then you've got how many zeros it would be. This chart is very handy. Okay, we were just talking about a 40,000 ohm resistor, which should be yellow, black, orange. And I've actually got one right here. There's a little orange dot in the middle. So where's my meter at? Here it is. We're going to read that, and it should measure around 40,000 ohms. Okay, and it measures 61,000. So that is out of tolerance. I'm not sure what percent high that is, but it is out of tolerance. We're going to have to change this one. So to change it, we're going to do the same thing we did to those capacitors. We're just going to nip this old one out and put a new one in there. So 40,000, 39,000 is close enough, which is what I've got right here. And also, another thing I had to touch on is these don't have, well, they do have somewhat voltage ratings, but they don't have them like capacitors do. This right here, we go by the size. This is a 1/2 watt resistor. Now let me zoom out. If you look at this one right here, that's a big one. That's probably a 1 watt resistor. Okay, I've got a replacement for that 40,000 ohm one, and it's right here. This is a 39,000 ohm modern 1/2 watt resistor. So that's going to go right in the place of that. So we're going to have to check all these in here and replace them if they're too far off value. I was over here on this end changing this resistor out, and I thought it'd be a good idea to demonstrate the pigtail method of soldering. So that's what I'm going to do now. So what you have to do is you find a small screwdriver or something around. I use this one. This is a very small jeweler's screwdriver, and you take your resistor here and you wrap the lead around. Make a little, what looks like a pigtail, and then you smush it all together, and then cut off the excess. So what you've got now is a little pigtail, and part of that lead I cut off. What we can do is we just slip that on there and solder it, and you can unsolder it easy too. Just melt the solder and pull it right off. So that is the pigtail method. It takes a little more time than J-hooking, but the most important thing to soldering two leads together, you have to make a good mechanical connection. Very important. You just can't hold them up next to each other and solder them, because that's not very strong. You have to make a good, solid mechanical connection. Okay, that's that. I'm going to go through and check the rest of these, and then we'll move on to the next part. Okay, I've checked and changed a bunch of the resistors. I checked them all. I changed 4 or 5 of them. But we're just about done with the underside of the chassis. One more thing I like to do. Now, since this is a power transformer set, one thing I like to do is add an inline fuse for safety. So I've got this. This is a 2 amp, 250 volt pigtail fuse. And here are this one and this one. That's the line cord coming into the radio. So what we're going to do is we're going to cut one of them. So I'm going to try to unsolder it. No, I'm not. I'm going to cut it. A lot easier. cut a little bit more off. Right there. Then we're going to strip that wire back. We're going to solder this. Okay, and I'm going to do pigtail method on this little fuse again, so I can wrap it around that line cord I just soldered. And there it is. A little bit big. We're going to put that right there. And I'm going to smash a little bit. Okay, then we're going to take some heat shrink. I'm using clear, so someone else can tell there's a fuse inside here, like the next owner. And then we're going to shrink it, if I can find my torch. I think it's too cold out here. Whoop. I wasn't watching. Okay, don't try not to burn it like I just did. Okay, I'm going to have to get another piece. So I burnt a big hole in it. Actually, that hole may not matter. It's not going to touch anything else. And I don't really have another piece handy. I don't know where I put my other ones. So we're just going to solder that on right down there. And it's not going to touch anything else. Okay, that's on there very, very good. As far as I know, that completes the underside of the chassis. So I'm going to flip this over and we're going to try to power it up and see how good it works. And I'll have to get that in the next camera shot. Okay, we are ready to test this radio. And I'll show you my setup. So we've got the radio. And here's the cord. We have it plugged in to my combination amp meter. come on, focus, and dim bulb tester. And then it goes into this variac, which I can dial it from 0 all the way up to 120. I can bring it up slowly. And I've got a watt meter right here. So we're just going to bring this up slowly. And the purpose of the dim bulb tester is if the radio's got a short in it, that light bulb will light up very brightly and it'll protect the radio. This will limit the current to the radio, and this will take the hit and the radio will not. The purpose of this variac is so we can bring the radio up very slowly and watch for any smoke, or if we hear any weird noises, anything like that. My amp meter is simply to see how much current the radio is drawing. So if this needle spikes, I'll know there's a short in it. And same thing with my watt meter. Okay, I'm going to put my camera back in its stand here. Okay, the radio is on. The volume is all the way up. I'll turn my heater off here. And we're going to start to slowly turn this. It's about 40 volts. And we can see the dial lights are lighting up. There's 60 volts. It's about 16 watts. That sounds good. This radio draws, I think, about 100 and... let me check. 110 watts when operating. Okay, there's about 70 volts. 24 watts. And we don't have... Wait. We don't have a speaker. Hold on. Scratch that. We gotta have the speaker hooked up. Okay, I'm gonna put this radio in the cabinet. And then I'll be back. Okay, I've got the radio in the cabinet now. I almost forgot it has to have the speaker hooked up. Because I can get this right there. This speaker has a field coil, and here it is on the schematic. The field coil is actually part of the power supply, so we have to have it hooked up for the radio to work. I mean, obviously you're not going to get any sound with no speaker hooked up. Anyhow, I just got a little carried away. We're at 60 volts. About 16 watts, 80 volts, 30 watts, 90 volts,
38 restos humanos de el género ni la edad.
Sounds like we're on short wave.
Was, for example,
okay, here's AM. Sounds like it's working good. We're only on 90 volts, 40 watts. This radio pulls about, I think it said 110.
because the city was told, okay, this is it, this is all we're doing. And then they come back and they say, well, this isn't really.
And we've still got the light bulb in series.
Stuff that needs to be done anyway. Can you tell us right now that there will be an open pipeline of conversation both directions between?
Okay, so there's no shorts in it. We're going to plug the radio straight into the wall.
council and talk about important issues.
About
like
82 watts.
or any of these things.
It's a little low.
What's on people's minds, because I think it would make us all better. Meet with the city council once a month, county commissioners once a month.
We forgot to clean the controls. We'll do that next. The radio's not finished yet. We're just with the track.
But I try to get all
It's working good.
And I try to bring big.
Okay, that hurt them. Ryan Shazier getting hurt. That really hurt him last year.
There's not much on shortwave. Okay, next we're going to clean the controls. And then I think that's about it. So we're going to touch up the cabinet. And then we're going to have to do an alignment. But we'll have to have the radio in the cabinet to do that. Because we're going to have, see this radio has an antenna inside the cabinet. I'll spin it around and show you. Is that in the camera? There we go. Okay, right here is the antenna connections. And it goes down into here, and then here's where you can turn it to get the best reception. But it's got a big old wire antenna, like a big cylinder with wire wrapped around it, and it's called the Truetone Stratoscope. And we're going to have that hooked up to properly align this radio. One thing I forgot about was lubricating the dial string. Now each of these little pulleys and this part down here that spins, basically everything that moves. Let's see, and then these parts in here, come on, focus. These parts in here, and there's some bearings up front. All those points need to be lubricated. And it always helps to put some lithium grease on the top here, where this thing slides back and forth. I'll keep it quiet. It's kind of scratchy right now. And then we're going to flip it over and we're going to spray the controls out. And then give it a quick alignment. And then we'll be done. This is my choice of control cleaner. And what you do, normally there's a little hole. See, this right here is the volume control. And normally there's a little hole that you can fit this little nozzle in and spray it in there. But that's not the case with this one. I actually had to take it apart a little bit to spray it out. This one, I bent this little tab right here, and I made it to where you can slightly pull this out. And I just sprayed a little bit of this in there, and you work it back and forth, and that'll clean it. And I did it to this one too. I lubricated the all the moving parts associated with the dial string. It's nice and quiet now. And I cleaned this one. This is the band switch. This selects between AM or the one shortwave band. And we're going to put it back into the cabinet now. I'm going to show you how to align it. I'm going to have to hook up some of my test equipment here. So stay tuned.
We were gathering stars while a million guitars played our love song. When
There it is. I did align it off camera, but normally when you print off a schematic, you'll have the alignment instructions. And it's pretty simple. You just have to follow through and do all this. And you'll need a frequency generator and a let's see, what is that? Oh, a frequency counter. And I used my output meter, and you'll get it really spot on. This radio is a really hot player. I love it. It sounds good. Like, the only thing left to do is touch up the cabinet. It's got some finish loss on top. But I'm going to go ahead and make this the end of the video, because it's gone on long enough. So I hope you got something out of this. I hope you enjoyed it. Stay tuned. Subscribe to my channel. And hopefully soon I'll have more videos. I've got plenty of stuff to get to. Like, next I'll do a video on this one. It's a Tombstone radio. This is a Silvertone. Probably mid to late 30s. Or I could do a television video. I got a late 40s Admiral. I've got the 59 Philco Predicta. I don't know, I'll have to see what I want to work on next. But anyhow, thanks for watching.